record a video for week 7, day 3. Our question of the day is, what is the fastest roller coaster in the world? Your choices are Ijanika in Fuji-Q Highland, Formula Rosa in Dubai, X2 in Magic Mountain, or Ghost Striker in Great America. In the meanwhile, I'm going to go over the announcement for today. If you haven't got a chance to come to take our makeup quiz yet, our makeup quiz will be tomorrow, Friday, during lunch or after school. Our survey for your family to choose between hybrid or distant learning, it has been extended to Sunday. Please take a moment to fill it out with your family if you haven't done so yet. Last but not least, the last day to turn in all makeup work will be Wednesday, March 24th. Now, let's go back to our question. What is the fastest roller coaster in the world? Let's start somewhere close, in Great America. The Ghost Striker is the tallest and fastest wooden roller coaster in Northern California. It goes as fast as 53.7 miles per hour. X2 in Magic Mountain, it goes as fast as 76 miles per hour. Over in Japan, Ijanika, the 4D roller coaster that we see, it goes as fast as 126 kilometers per hour. When we convert it to miles per hour, it is around 78.3 miles per hour. So it's similar to X2, but slightly faster than X2. Then what is our number 1 place winner? Our top place winner will be Formula Rosa over in Dubai. It goes as fast as 149 miles per hour. If you would like, go ahead and click on the link in the description below to see how Formula Rosa feels like. Today, we are going to learn about the science behind roller coaster. Last time, we talked about the different top roller coaster around the world, but what makes roller coaster work the way it does? What are some questions you have about roller coaster? Let's take a look at the next video.
What I wonder. Scream machines. Hi, I'm Jennifer Barone, an editor on Science World magazine. We recently ran an article about 3 amazing new rides engineers created for Six Flags. That got me thinking about the last time I took a spin on a roller coaster. It was the Coney Island Cyclone in Brooklyn, New York. It's a wooden roller coaster that opened in 1927. The Cyclone doesn't go upside down like a lot of the newer roller coasters do, and it's nowhere near as fast, but it was still really exciting. Today's rides move in much wilder ways. Reading about them made me wonder, what would it be like to see these rides in action? Luckily, Six Flags had some video clips and computer simulations that could help me find out. Let's check them out together. Our goal is for you to practice asking questions about the phenomena that you're seeing. So as you watch, pause after each clip and write down at least one question that you have. Here are some of mine. Why doesn't the roller coaster fall off the track when it flips upside down? Is the experience different for riders on the ends of the rows compared to the ones in the middle? What's causing the riders to spin as the pendulum swings? engineers who build rides have to address all these questions and more. Here's one more question for you. Would you brave these wild rides?
So with that, let's take a look. The essential question that we want to ask is, what force do engineers need to consider when designing amusement park rides? As we are reading this article, we are going to be focusing on kinetic energy and potential energy. Let's read this together. Engineers share the secrets behind some of the newest and craziest theme park rides. This summer, millions of people will flock to amusement parks, seeking the latest thrills. Engineers at Six Flags theme park have been working hard to ramp up the excitement. Last season, they launched a gravity-defying ride that twists and spins in 3 directions at once. To top that, this year they're introducing 2 new record-breaking attractions: a high-speed roller coaster and a swinging pendulum that sends riders soaring high in the air. Engineers who designed these over-the-top rides need a big imagination and an in-depth knowledge of physics to deliver new experiences that are both safe and exhilarating. Here's how they combine creativity and science to make 3 of the most stomach-dropping, heart-pounding, scream-inducing rides yet. As we're reading this together, think about what are the key points of potential and kinetic energy. You can use the pencil tool, the highlighting tool, the line to highlight any of the key points that you see. Again, the self-paced link for Peer Deck is listed below in the description. Max Force. Roller coaster enthusiasts will flip head over heels literally for max force. The new attraction breaks records for the fastest inversion, or upside down turn, and tallest double inversion in the world. It also has the fastest start of any coaster in North America, rocketing riders from 0 to 126 kilometers, 78 miles per hour in less than 2 seconds. It is intended to stick you to the back of your seat, said Michael Reeds, a mechanical engineer at Six Flags. Every roller coaster track has different loops, rolls, and drops, but despite roller coasters' different designs, they all work on one similar principle. What a roller coaster does is convert some sort of potential energy into kinetic energy, says Jeff Rhodes. He's a mechanical engineer who teaches a class on roller coaster dynamics at Purdue University in Indiana. With max force, potential energy is stored in tanks of compressed air. The air is released in a powerful blast when the ride starts. It launches the coaster down the track, converting the stored energy into kinetic energy, the energy of motion. This differs from a traditional roller coaster, which has a chain that pulls it to the top of its first incline. As it rises, the roller coaster gains potential energy because of its height. The force of gravity then pulls the coaster down the track, converting its stored energy into kinetic energy. Once max force launch, its energy gets converted back and forth from potential to kinetic energy as it moves up and down through inversions. Some energy is lost to drag, a slowing force caused by air molecules pushing against the coaster as it moves. The force of friction also slows down the cars as their wheel rub against the track. But max force initial launch blast is more than enough to rocket the ride all the way to the end of its course. At this time, pause this video, take a minute to highlight any key point on kinetic or potential energy. Let's take a look at how max force works. First, a blast of compressed air launched the coaster. It made the coaster travel all the way up to 175 feet. Right here on the top, that's when they're going to have a double inversion. The coaster will come down through gravity, and then they're going to speed up again to prepare for the second inversion. And right here, before they come to a stop, they will have a second double inversion. Is there any key that you see about kinetic or potential energy here? Feel free to pause the video to mark any key points that you see. Number 2. Wonder Woman Lasso of Truth. Wonder Woman Lasso of Truth is a record-breaking attraction with a twist. At 17th story, it's the world's tallest pendulum ride. People sit around the outside of a disc attached to a long arm. Motor rides the arm high up and then let it drop. The pendulum swings to the other side, rising until it pauses in midair. At that moment, it has zero speed. Basically, all of the energy is potential then, say Rhodes, but as you swing down, you are going to pick up speed. On its own, a pendulum continues swinging to almost the same height each time because of inertia. That's the tendency of an object to keep moving unless acted on by an outside force. A little height is lost to drag and friction. But on the ride, motor boosts the pendulum higher as it sways. At the peak of each swing, it has more potential energy than it did last time because it's higher, says Reeds. Riders sweep through the bottom of the arc, the point with the greatest kinetic energy, at speeds of up to 121 km or 75 miles per hour. As the disc swings, it simultaneously spins riders in counterclockwise circles. Each time a rider passes through the same point in the swing, he or she is in a different position on the disc. It's a very cool sensation, say Reeds. It's almost as if you are moving back and forth in a wave motion. Please pause this video at this time and highlight any key point you see on potential or kinetic energy. Let's move to our last part. Cyber spin. This 7-story ride began turning riders topsy-turvy last year. They strap into a row of seats along the bottom of a giant frame. It's attached to pivot that allow it to rotate inside an even bigger frame, which rotate inside a gigantic frame. Each frame has its own axis of rotation, or line around which it turns, say Reeds. You can be spinning multiple axes at any given moment. This ride was inspired by a gyroscope, a device with wheel mounted inside a larger wheel that can spin freely. Gyroscope detect orientation in planes, ships, and even smartphones. The inner wheel of a real gyroscope spins in a fixed rotation, even when the device is tilted. Designer decided that wasn't wide enough for the new ride. Motors turn the nested frame at the point where they connect, so rider on the inner frame spin in what feels like every direction imaginable. As riders flip, gravity pulls them into and then out of their seats. Ray says the experience is disorienting because you sort of get lost in where you are. Please pause this video and find key points on kinetic and potential energy. One of the key points that we see right here is energy cannot be created or destroyed. Think about how that can apply to roller coaster. With that, in the second part of the class today, we are going to be designing your own energy skate park. When we met yesterday on Wednesday, we try out different energy skateboard design and you explore the website. Today, you'll be finalizing your energy skateboard design. We'll be working on the first three parts, thinking of a name for the energy skateboard, making a diagram for your energy skateboard, and adding a description to your energy skateboard. First, you are going to go to tinyurl.com/designmyskateboard. You can also find this link in the description below. Next, click on Playground. You can use the 5 given track on the bottom to explore different skateboard design. In order to take a screenshot, you can click on the 3 line on the bottom of your FED simulation. Here are other options you can use to take a screenshot. Again, if you take a screenshot from FED, you can upload a picture by clicking Insert, Image, Upload from Computer. Let's take a look. Insert, Image, Upload from Computer. Second, you can also use your computer screenshot option. Here are some ways that you can take screenshot on different types of computer. If you are using this Google Chromebook, you can click Control, Shift, and this box with 3 lines on the side. If you are using a MacBook, you can click on Command, Shift, and number 4. If you are using a PC, you can click Window and Print Screen. If neither number 1 or number 2 work for you, you can also try option 3 and 4. Option 3, you can draw your skateboard on a piece of paper and take a picture on your webcam. In order to do that, you can click Insert, Image, and Camera. Let's take a look. Insert, Image, Camera. If that method does not work for you, you can also try option 4. You can draw your skateboard directly on the Google slide by doing Insert, Line, and Scribble. Let's take a look. Insert, Line, and Scribble. Then you can draw directly right here on your Google slide. With that, today we will be focusing on the first 3 parts, coming up with a name, taking a screenshot, and writing a description in complete sentence. If you have any question, please reach out to me. I will see you next time. Bye!